In this episode, we focus on a privacy question that sounds simple but turns out to be surprisingly tricky. How do you tell whether the training data behind an artificial intelligence (AI) system creates privacy risk? And how do you tell whether the model's behavior creates new privacy risk after it is built? Beginners often imagine privacy as a single gate, like removing names and then declaring the data safe. Real privacy risk is more like a chain, where a weak link anywhere can expose someone, even if other parts look careful. Training data can contain sensitive information, can be collected in ways people did not expect, or can be combined in ways that identify someone indirectly. Model behavior can also create privacy problems by revealing, memorizing, or inferring details that were never meant to be output. By the end, you should be able to approach an AI system with a clear, practical way to validate privacy risk without needing to be an engineer. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A good place to begin is separating two related ideas: privacy risk in the dataset and privacy risk in what the model does with that dataset. Dataset risk is about what is inside the training material and whether it should be there in the first place. Behavior risk is about what the trained model can reveal or infer when it receives a prompt, an input record, or a question. This distinction matters because teams sometimes focus only on one side. They may scrub obvious identifiers from the data, but never test whether the model can still leak sensitive information through its outputs. Or they may test the model's outputs, but ignore that the data was collected without proper permission, which creates privacy harm even if the model never leaks anything. Validating privacy risk means checking both: the input pipeline that feeds training and the output pathways that expose information to users, systems, or other models. When you keep these two halves in mind, your questions become sharper and your evaluation becomes more reliable. Training data privacy risk often starts with a basic question: what kinds of people-related information are present, and are they necessary for the purpose? A dataset can include direct identifiers like names, email addresses, or government IDs, but it can also include indirect identifiers like a rare job title paired with a small town and a unique timeline. Even if direct identifiers are removed, combinations of attributes can still point to a real person, which is why privacy is not solved by deleting one column. Another common risk is sensitive content embedded in text fields, like customer support notes, medical descriptions, or personal circumstances shared in messages. These details are often included accidentally because free text is messy and humans write too much when they are trying to be helpful. When you validate training data, you are checking not only the obvious fields, but also the hidden corners where personal details tend to collect. A beginner-friendly way to validate the training data is to focus on origin and permission, because privacy is strongly tied to how the data was obtained. If the data came directly from customers, students, patients, or employees, what did those people think would happen to their information at the time it was collected? If the data came from a third party, can the organization explain how the third party collected it and what rights were granted for reuse? If the data came from the open internet, was it collected in a way that respects context, or was it scraped at scale in a way that defeats normal human expectations? People share information in one setting with a certain audience in mind, and privacy harm often happens when that context is ignored and the information is repurposed for model training. Permission also includes whether consent was meaningful, specific, and tied to the actual use, not a vague umbrella statement. If the organization cannot tell a clear story of permission, privacy risk exists before the model even begins learning. After origin, look at scope, because privacy risk grows when data collection becomes broader than the purpose requires. A team might start with a reasonable goal, like improving customer support suggestions, and then quietly expand the dataset to include chat logs, browsing behavior, location history, and purchase patterns because more data feels like better results. This is where the principle of minimization becomes practical. Only collect and use what you truly need. Minimization is not about being anti-data. It is about reducing exposure and preventing surprise. Beginners can validate minimization by asking why each major category of data is needed and what would happen if it were removed. If the answer is vague, such as "it might help," that suggests the team has not thought through privacy trade-offs. A responsible design treats personal data as a liability that must earn its place, not as a free resource that can be poured into a training pipeline. Another training data risk is retention, because data kept longer than necessary increases the chance of misuse, breach, or accidental leakage into future systems. Retention matters even when data is handled securely, because time changes the context. A piece of information that was acceptable to store for a short period, like a support interaction, can feel invasive when kept for years and used to train new systems far removed from the original interaction. Retention also interacts with deletion requests, because privacy programs often require honoring requests to remove a person's information. If a dataset is used to train a model, and there is no clear path to ensure removed data is no longer influencing the system, that creates a mismatch between privacy promises and technical reality. You do not need to know the mechanics of model updates to validate this risk. You need to ask whether the organization has a defined process for retention limits, deletion handling, and documentation that connects those processes to model training. Now shift to model behavior, because even a carefully sourced dataset can produce a model that behaves in privacy-threatening ways. One major behavior risk is memorization, which is when the model retains specific details from training and can reproduce them later. This risk is easiest to understand with a human analogy. If you read thousands of documents, you might remember a few unique phrases, names, or rare facts, especially if they stood out. Some models can do something similar, especially when trained on sensitive text that includes unique identifiers or highly specific details. The danger is not only that the model might repeat a name, but that it might repeat a phone number, an address, a private story, or a confidential internal snippet. Validating memorization risk means testing whether the model can be prompted to reveal training-like content that should never be output. This is less about catching every possible leak and more about determining whether the system has guardrails and whether those guardrails are effective. A second behavior risk is inference, which is when the model guesses private information that was never explicitly provided in the input. Inference can happen because models learn patterns, and patterns can be used to predict sensitive traits. For example, a set of behaviors might correlate with a health condition, a life event, or a demographic category, even if the dataset never included that trait directly. If a model is used to personalize content, rank applicants, flag risk, or make recommendations, it may infer sensitive things and treat the person differently based on that inference. This can feel invasive because the person did not consent to being analyzed in that way, and it can be harmful if the inference is wrong or used to make high-stakes decisions. Validating inference risk involves asking what kinds of conclusions the model could draw from available signals and whether the organization has rules that prevent sensitive inferences from being used. It also involves considering whether the model's outputs encourage users to trust these inferences as truth. A third behavior risk is linkage, which is when model outputs help connect separate pieces of information into a clearer picture of an individual. A model might not output a full identifier, but it might output enough details to narrow down a person's identity, especially when combined with other data. For example, a summary might mention a specific role, a specific incident date, and a specific location, which could be enough for someone inside an organization to identify the person involved. In organizations, linkage risk can be especially dangerous because internal users often already have partial knowledge, and the model's output can complete the puzzle. Validating linkage risk means thinking like an insider and asking how outputs might be combined with what users already know. It also means checking whether outputs are limited to what the user needs for the task, rather than providing rich narrative detail that creates unnecessary exposure. To validate behavior risk in a practical way, focus on use cases and access, because privacy harm depends on who can ask the model questions and what they can do with the answers. A model available to the public has different risk than a model restricted to a small group with training and monitoring. A model embedded in an internal workflow can still be high risk if it is widely accessible across departments, because different departments have different needs and different ethical boundaries. You can validate this by asking what authentication exists, what authorization limits exist, and what logging exists to detect misuse. Logging matters because without it, privacy abuse can hide behind normal-looking usage. You also want to know whether sensitive prompts or outputs are stored, because storing model interactions can create a new dataset of personal information that did not exist before. A careful privacy review treats the model interface itself as a data collection channel that must be governed. Another practical validation step is to look for red flags in the training content categories that commonly cause privacy trouble. Free text sources like emails, chat transcripts, support tickets, and internal documents are frequent culprits because they contain unstructured human detail. Images and audio can be even higher risk if they include faces, voices, or other biometric signals, which can be used for recognition and identity. Children's data and student data deserve extra caution because expectations are higher and potential harm is greater. Health and financial details also raise the stakes, even when the organization believes it is using them responsibly. You do not need to memorize every law or rule to validate risk. You can recognize that these categories require stricter justification and stronger controls. A privacy fit that works for generic product data may fail completely for a dataset that includes highly personal narratives. Validation should also include checking whether the model's outputs could create privacy risk through overconfidence and authority. Even if the model never leaks a direct secret, it can present guesses as if they are facts, and that can lead users to act on sensitive conclusions. For instance, a model might summarize someone's behavior as indicating a particular personal situation, and a user might treat that as a reliable assessment. This matters because privacy harm is not only about disclosure. It is also about being analyzed and categorized in ways that are intrusive or unfair. A good validator asks whether the system clearly limits what it claims and whether it avoids presenting sensitive inferences as certain. You can also check whether users are encouraged to input personal data into prompts, because user behavior can turn a low-risk model into a high-risk system. If people start pasting private records into prompts, the privacy risk expands immediately, especially if prompts are logged or used for future improvements. One of the most effective ways to validate privacy risk is to require that the organization connects the dots between identified risks and specific controls. Controls can include data filtering to remove obvious identifiers before training, access controls that restrict who can use sensitive capabilities, and output restrictions that reduce the chance of revealing personal details. Controls can also include monitoring for unusual usage patterns, review processes for new data sources, and clear rules about what kinds of questions the model is not allowed to answer. The important point for beginners is that controls should match the risk pathway. If the risk is memorization of personal details, the controls should address memorization and output leakage, not only network security. If the risk is inference of sensitive traits, the controls should restrict how outputs are used and what features are included, not only redact names. Validation is about checking that the control story makes sense, not just that controls exist somewhere on paper. It is also crucial to validate privacy risk over time because models and data pipelines evolve. A system that begins with a limited dataset can later ingest new sources, and a system that begins as internal can later be exposed to a broader audience. Privacy promises can also change as policies and expectations change. This is why a one-time approval is rarely enough. There should be a repeatable review trigger when data sources change, when the model is updated, or when the use case expands. As a beginner, you can validate this by looking for a change management habit, such as requiring review before new training data is added or before the model is repurposed for a new decision. If a team treats model updates as routine technical work with no privacy review, that is a warning sign that privacy risk will quietly accumulate. Good governance treats AI systems as living systems, not as one-time projects. To bring it all together, validating privacy risks created by training data and model behavior is about tracing how information moves, how it can be revealed, and how it can be used. Training data risk asks whether the organization had a right to use the information, whether the scope is minimized, whether retention and deletion are handled honestly, and whether sensitive categories are treated with the seriousness they deserve. Model behavior risk asks whether the trained system can memorize, infer, or link personal details in ways that create exposure, and whether access and logging limit misuse. The practical mindset is to think in pathways: what goes in, what is learned, what can come out, and who can see it. If you learn to validate privacy risk with these pathways, you will be able to ask sharp questions, spot weak explanations, and push for controls that match real risks. That is the heart of responsible oversight, making sure an AI system does not turn people's information into a silent liability that grows the moment the model is turned on.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.